Hello Unites and welcome back to Mathemagic. In today's lesson we're continuing with looking at linear relationships and we're back to looking at regular lines on a Cartesian plane, not just line segments that we looked at last lesson. Now in today's lesson we're going to be talking about parallel and perpendicular lines. So by the end of today's lesson there's four things we want to be able to do. We want to explain what parallel and perpendicular means. We want to identify the conditions for parallel and perpendicular lines, and we also want to be able to find the equations for parallel lines and also for perpendicular lines. So four things. It looks like we've got a lot of things to do for today's lesson with the success criteria, but let me tell you, once we get the hang of it, it's not going to be too bad. So let's first talk about what parallel and perpendicular lines are. Now here, we've got two definitions we're going to talk about. So parallel lines and perpendicular lines. Now parallel lines, two lines are parallel if they do not intersect. Let me get this closer. Do not intersect or touch. And so here I've got this little GIF from one of my favorite Disney movies, Emperor's New Groove. So here, what it means for two lines to be parallel, it means that they are not touching, no touchy. So what that looks like, if I have my Cartesian plane here, I've got an example of a line here, the one that's in black. A parallel line would look something like this. It would be not touching. It never touches the line, and notice here it kind of goes like that. Something like this. This is an example of a parallel line. And so parallel lines, this happens if they have the same gradient. Now, in order for us to have two lines being parallel, that means that their gradients are the same. So how we write, the test that we use for this is if m1, so the gradient of my first line, so gradient of line 1 is equal to m2. So m2 is just gradient of my second line, of line 2. So if the two gradients are the same, so notice here the gradients are the same, they have the same steepness. That means that they're never going to touch. They're going to have no touchy. So parallel lines are lines that do not intersect or touch, and that happens when the gradients are the same. Now the second one is perpendicular. Now the definition for perpendicular is two lines are perpendicular if they touch at 90 degrees. So here on my diagram again, an example of a perpendicular line is if I drew a line that went this way, like this, and notice if I draw a line that goes this direction, let me move it across so I can actually draw, you can see it a little bit better, like this. This is an example of a perpendicular line. So let me just label it on here, perpendicular. And so notice this line and the original black line that I have, they touch at 90 degrees. They form a 90-degree angle at where they intersect. And so here, the condition that we have is that if we want two lines to be perpendicular, they have to fill the following criteria. M1 times M2, so the gradients of my first line and the gradient of my second line, if I multiply them together and they give me -1, that means that they are perpendicular. Now we can actually rearrange this formula. So here, notice here we have M1 times M2. I can rearrange this to help me find the gradient of one of these lines. So what we need to notice here, if I rearrange this for M1, notice here we're timesing by M2. So what I need to do is if I want to get rid of that times M2, I need to divide by M2. So here, that will just mean that it's equal to -1 over M2. And so here, what this actually means is this is the negative reciprocal. When you see 1 over a particular number, that's the reciprocal. What that means is we flip any fraction, for example, upside down. So, for example, if my first gradient was a half, that would mean that the gradient of my perpendicular is going to be the negative flipped version. So it's going to be my gradient of my perpendicular is going to be -2 over 1. Now we don't write 2 over 1. That's just the same as saying -2. So that's how we can actually use this formula to help me find the gradient of a perpendicular line. So let's just talk about this. Let's just quickly sum up here. Parallel lines are lines that do not touch or intersect. So they do not touch or intersect. No touchy. And what this means is that their gradients need to be the same. M1 needs to be equal to M2. For perpendicular lines, there are lines that meet at 90 degrees, like the green line in our diagram. And in order for us to have a perpendicular line, the gradient of my original line and my perpendicular line needs to be multiplied to give me -1. Or they need to follow this pattern of m1 is equal to negative the reciprocal of m2. Okay. So what we want to be able to do is we want to be able to identify if lines are parallel or perpendicular. So let's scroll down here and have a look at this question. Determining if lines are parallel or perpendicular. For this, we just want to use those two conditions. If a line is parallel, that means the two gradients are the same. So m1 is equal to m2. If they're perpendicular, what we can say is if I multiply the two gradients, that should give me -1. And so those are the two conditions I'm going to use for these questions. Okay, so let's have a go at these two questions. Decide if the graphs of each pair of lines will be parallel, perpendicular, or neither. So let's have a look at the first one. I've got y is equal to 4x plus 2 and y is equal to 4x minus 6. Now what we want to do first is we want to identify the gradients of these two lines. Now here we've actually written it in a form where we can read off the gradient quite easily. This is gradient intercept form. And so what we can do here is if I want to find the gradient, well, the gradient of my first line, well, if you remember from gradient intercept form, y is equal to mx plus b. And all we need to do is just match up where m is. In this case, it's 4. So my gradient of my first line is 4. For my second line, I'm just going to follow the same pattern. m2 is equal to, well, the number before the x is 4. And so here, my gradient for this one is 4 as well. Notice here, these two have the same gradient. So if they have the same gradient, what do we know about the two lines? Well, the two lines are going to be parallel. So here I'm going to write m1 is equal to m2 because we can just look at those numbers and be like 4 is equal to 4. Makes sense. And so therefore, the lines are parallel. There we go. Okay. So for the first one, these were parallel lines because they had the same gradient. Let's have a look at the next example. This one over here. So here we've got y is equal to -3x and y is equal to 1/3 x. Okay, same steps that we did before. We're going to first identify the gradients. So let's have a look at the first one, m1. If this is my first line, what's the gradient? Well, we've got y is equal to -3x minus 8. And so we're just looking for the number before the x, which happens to be -3. So this is going to be -3. Okay, that's my first one. I'm going to need to do the same thing for my second one, m2. The number before the x is 1/3, 1/3. Oh, let me write this in blue. 1/3. Okay, so we've identified our gradients. Now notice here immediately we're like, okay, -3 and 1/3. They're not equal. Okay, so what we want to check, so that means that they're immediately not going to be parallel. So from here we can actually check, okay, are they perpendicular? Are they perpendicular? So here, what we want to check is m1 times m2. So if I multiply the two gradients, we want to have a look at what that number is. So let's write that down. So here, m1 is -3, and I'm multiplying that with 1/3. Now, -3 times 1/3 will just give me -1. Okay, cool. So here we've got, when we multiply the two gradients, that equals to -1. Okay, if that's the case, that means that they have to be perpendicular. So therefore, lines are perpendicular. So if they multiply together and give me -1, that means that the lines are perpendicular. So let's just quickly sum up here. Here we just use the conditions for parallel and perpendicular lines. Parallel lines have to have the same gradient. Perpendicular lines, when we multiply their gradients together, they equal to -1. And we just check whether or not these two, they follow those conditions. And if they do, they're either parallel or perpendicular. If they don't, the gradients aren't equal, and if they don't multiply to -1, that means that they are neither perpendicular nor parallel. Okay, so that's this first part, just identifying whether or not lines are parallel or perpendicular. What we want to do from here is actually want to find the equation of lines which are parallel or perpendicular based on certain conditions. So, finding the equations of a parallel or perpendicular line. For these questions, we're just going to follow the same steps. Even if it's parallel, we're going to follow these steps. If it's perpendicular, we're going to follow these steps. Doesn't matter. So, the steps we're going to follow. Like we did when we were finding the equation of the line 2 lessons ago, we want to first write the gradient intercept form for the line. So here, if you remember, y is equal to mx plus b. So first step is to write down the gradient form for a line. Okay, gradient intercept form for a line. Then the second part is we want to identify the gradient of the line and replace m. So just like we did in when we're finding the equation of a line, we want to do the same thing. We just want to replace m with the gradient. And so here we need to actually check. If the line is parallel to another line, the two gradients need to be the same. If it's perpendicular, it needs to be the negative reciprocal, or they need to multiply together to give me -1. And the third step is to substitute the value of a coordinate given to find the y-intercept. So here in the questions, they're going to give us another point that we want to substitute in, and that will give us the y-intercept. And we need to sub that in to solve for the y-intercept. Okay, so let's have a look at this, these questions here. So that's for B. Okay. So here we want to find the equations of the line with the given condition. So we've got two examples here. Let's have a go at them. So let's have a look at that first one here. A. The line is parallel to y is equal to 3x minus 1 and passes through 0, 4. Okay. First step, write the gradient intercept form. So I'm going to write here y is equal to mx plus b. Okay, I've done that. Now what I want to do is identify the gradient. Now here, in the question, they tell me it's parallel to this line here. So what we know is if it's parallel, it has to have the same gradient as this line here. Now this line, what's the gradient of this line? This line has a gradient of 3. So what I need to say is, well then, if that has a gradient of 3, my line which is parallel also has to have a gradient 3. So I'm just going to write here m is equal to 3 and just sub it in. So here I'm going to have y is equal to 3x plus b, like that. So here I found the gradient of the line by identifying the fact that this first line, it was parallel to this first line. So it has to have the same gradient. Okay. The next step is then to substitute the point, any point that we have to find the y-intercept. Here, they give me the point 0, 4. Now, if you think about that point for a second, 0, 4. If I was to put that on a Cartesian plane, 0, 4 would be all the way up here on the y-axis. So what this actually tells me is that this 4 is my y-intercept. And so all I can do here is I just know, okay, if that's a y-intercept, that's just a value of b. And I can substitute that straight into here. So final step is going to be just writing it out. So y is equal to 3x plus 4. The 3 came from the fact that the gradient of the line had to be parallel. Our line here had to be parallel to y is equal to 3x minus 1. So that means that it has to have the same gradient. The 4 came from the fact that here, when we substitute this line, we realize that 0, 4, any number where you have 0 and a number, that's on the y-axis. So automatically, this just becomes my y-intercept, b. Okay, so that's this first example here. We wrote the gradient intercept form, we found the gradient, and we found the y-intercept. Let's have a go at another example. Here, this one. The line, we want to find the equation of a line which is perpendicular to the line y is equal to 2x minus 3 and passes through 0, 1. Okay, first step, just like we did before, y is equal to mx plus b. We're just going to write that gradient intercept form out. Okay, what do we know about the gradient? This time, the line is perpendicular to the line y is equal to 2x minus 3. What this means is the gradient of this line that we have here needs to multiply with the gradient of this line up here to be -1. Now, what's the gradient of this line over here? This line has a gradient of m is equal to 2. That's just a number here. So if I want to find the gradient of my line, the gradient must be equal to, there's two ways that we can do this. We can go, okay, m1 times m2 is equal to -1. And so if my other line has a gradient 2, I can just sub in 2 here. And so I have m1 times 2 is equal to -1. And then divide by 2. So we have a multiply here. So we need divide to get rid of it. So therefore, m1 is equal to -1 over 2. That's one way you can do it. That's using that condition that we saw earlier in this lesson. But earlier in this lesson, I also wrote another condition that helps us to find the gradient of the line. This one over here. If we want to find the gradient of the perpendicular line, we can just sub it into this form here, -1 over m2. And so the other way that we can actually find this gradient is by going, okay, So that's one way I did it. The other way I can do it, right here, or M1, that pattern was M1 is equal to negative 1 over M2. And so M2 is just the gradient of this line here. And so I can just sub that in. So that's negative 1 over 2. If you're able to remember this method, this method is much quicker than actually having to solve it like the one over on the left-hand side here. So what I'm going to do now is I've got this value for M1. I'm just going to substitute this in. So here, my line is going to have the equation y is equal to negative a half x plus b. Okay, that's the first step. So we've written the gradient intercept form. We've actually found the gradient by noticing that with our perpendicular line, they need to multiply together to give me, the gradients need to multiply to give me negative 1. Or in this case, I use this alternative method, which is just rearranged version of this equation here. The next part is I need to find the y-intercept. So I need to use the point over here, 0, 1. Now notice here, this point again has a 0 for the x coordinate. So that means that this point is actually, if I draw my Cartesian plane, this point is over here at 0, 1. This is once again on the on the y-axis. So that just means that my y-intercept, or b, is just going to be equal to 1. And so I can sub this straight into my equation. And so therefore, my line's equation is going to be negative a half x plus 1, like that. And there we go. That's how we find the equation of our perpendicular line. So here, same steps. Gradient intercept form. Find the gradient, find the y-intercept. And here, when we have a perpendicular line, we need to do a few additional steps to actually sort of figuring out what the gradient, perpendicular gradient is going to be. So that's it for today's lesson. Let's do a quick summary of what we talked about in this lesson. In today's lesson, we started talking about parallel and perpendicular lines. So parallel lines are lines that do not touch, so no touchy. And the way that we know that if two lines never touch is if they have the same gradient. The gradient of the first line is the same as the gradient of the second line. The next one was perpendicular lines. Perpendicular lines meet at 90 degrees. And so in order for us to have perpendicular lines, the two gradients need to multiply to give me -1. And we could actually figure out whether or not lines were perpendicular or parallel by using these two conditions and identifying the gradients and checking whether or not they satisfy either of these two conditions. Are they equal or do they multiply to give me -1? That means that they're either parallel, perpendicular, and if they don't fit in both, they're neither parallel or perpendicular. Then we found the equation of parallel and perpendicular lines. And this was actually very similar to the steps that we would normally do if we were finding the equation of a line. Write the gradient intercept form, find the gradient, find another point to sub in. Now for these ones, for finding the gradient, we just need to follow those conditions. If it's parallel to another line, they have the same gradient. If it's perpendicular to another line, their gradients multiply to give me -1. And so here, there's two ways that we could do this. So that's it for today's lesson. If you need to go back and watch any particular section of this video again, feel free to do so, or send me an email or send me a comment in the Google Classroom for me to help you out. I'm more than happy to do so. But as always, you nines, I hope you guys are staying safe wherever you are. And until our next lesson, I'll see you then. Bye.